Okay, so today's session we will try to cover the basic aspects of Dockers, see what are the benefits, how does it work, and what are different use cases. So these are the topics at very high level. Docker architecture, component, installation, basic commands, what is a Docker file, how to create it, how to build a Docker image. Then we will talk about the public and private repositories, and then we will see how to create a web server using a Docker image. So Docker, if you say Docker is nothing but it's a computer software used for virtualization in order to have a multiple operating system running on the same host. So this is the text-based definition. But if we see, let's try to see what are the different how the things have been going or growing into the market or in the industry. So earlier we used to have machines where dedicated complete rack or hardware machine would be dedicated for running a single application. Okay. You would have an OS and then you will be running a complete application. Okay. Then that was a very basic traditional way of running applications, correct? And then we came across the concept of virtualization. So that virtualization was nothing but just creating the virtual machines using the hypervisors. So that where we had a single physical machine, we could install multiple OSs, and on the top of our OSs we could run our applications in a different environments. So if you see, this is the one which I'm talking about. So you have an infrastructure, then you have a hypervisor. So this hypervisor could be a hardware hypervisor or which runs directly on a bare metal piece of machine, or it could be a software hypervisor OS which itself is running another hypervisor Oracle virtual machine or any other hypervisor. So normally what happens you have an infrastructure, on the top of that you have a hypervisors. On the top of hypervisors you could install multiple operating systems, and just you are using a virtual machine or Oracle's virtual machine on your desktop, so that is providing you a operating system environment where you can run your operating system. So for example you have a Windows machine. On Windows machine you can run a Ubuntu, you could run iOS, or you could run some other maybe a Windows old version, Windows ME or Windows XP. So that is a concept of virtualization using the hypervisors, which provides you a different operating system environments to execute your programs. So these are the virtual machines which generally most of the deployments where not the modern but the old deployments happens. Okay, so we will see what are its advantages and disadvantages. Then we now have a new way of virtualization where the Dockers basically runs on a host operating system, but it provides you a isolated environment or isolated execution environment where you can run your application. So basically it comes with a two set of two layers. So one is the application execution environment, which basically is a kind of or what I would say, for example, you have a Windows machine, and on the top of that you are running a Docker host, and on the Docker host you could run a Docker image which might be using the Ubuntu libraries. So in that way, Docker will provide that conversion of Ubuntu to Windows API conversion, but your application would see like it is running under a Ubuntu execution environment. So that is basically a next level of containerization or next level of virtualization. So if we just go by definition, so unlike hypervisors, which are used for creating virtual machines, virtualization in Docker is performed on a system level, so called a Docker containers. So as you can see the difference in the image below, Docker containers runs on the top of the host operating system. Okay, so we will see how it improves the efficiency and what are its pros and cons on the top of virtual machines. So if you see here, this is a Docker architecture. So so it's basically a client server architecture. So you have a Docker host. So it's basically having a Docker daemon running. So you can run multiple containers in Docker host using the Docker images. Okay. So these Docker images, they are stored in the registry. So these registries can be local or remote. So whenever some client asks to build it, so Docker daemon will create the Docker images and it will push it to the registry. And when we request for a Docker pull, it will pull Docker image from the Docker registry. And when we run Docker run, it will generate a container using this Docker image. So we will see later how and exactly it happens. So before that, let's see if I have that picture. Okay, so let's see this picture again and try to see what are the benefits of Docker. So if you remember, when you create a virtual image using a Oracle VM or any other hypervisor, so while creating these virtual machines, you have to reserve a particular set of RAM. So say for example, you have to pre-allocate a 2 GB of RAM and for example 30 GB of storage. Correct. So these kind of so as soon as you create a new virtual machines, you have to reserve some RAM and some space. But in reality, it may happen like even though you have allocated 2 GB of RAM, but that application might not be using a 2 GB of RAM. So most of the time, system might remain idle, or sometimes it may happen like your utilization increases and the 2 GB doesn't remain sufficient for you. So that case is these virtual machines, they are not able to handle. So this causes either wastage of resources or sometimes your systems underperform because of low allocation of RAM or the other resources. Correct. So these are the problems with the traditional virtual machines. Okay. But if we talk about containers, so when we create a container, we don't have to specify how much RAM or space it would need. So basically, these Docker containers, they will be scheduled and executed on a host OS as a process. So whenever container is scheduled, it will have a full access to all the underlying resources. Correct. So it may be possible like application inside a container might not be doing anything. So it might be just idle or waiting for some resource to be available. So in that case, uh, just like no process scheduling happens, this container will not be executing. So it will be waiting in a waiting queue. Okay. So whenever it is scheduled, it will have a full access of whatever RAM or storage you have. So in that way, the application running in this container will be able to execute based upon what is the current requirement of the application. So in this way, it helps in improving the efficiency. It helps in reducing the resource wastage, and also helps in cost. If basically these helps in reducing the cost. Otherwise, what in this case, if I just take an example, both VMs, like three VMs, or at least 2 GB RAM, if they need, then we need to have a 6 GB of RAM at least for running these three virtual machines. But in this case, probably 2 or 3 GB of RAM would be sufficient, because at a particular time one container is running and it will have a 2 GB of RAM. So 1 GB maybe we can keep it for Docker, but in this way we can reduce the overall resource utilization. Okay, so do you understand what is the difference between containers and VMs, and why most of the people they are going forward and running behind the containerizing their application? So going forward, containerization or containers, Kubernetes, these will be a hot topic, and from DevOps perspective also, people would need your help in creating the Docker images to CI/CD pipeline, and probably deploying these Docker images on the infrastructure which we would be creating using Terraform. So this is where this container or Docker fits into the DevOps profile. Okay, so this, I think we will see later on how what are the different components and how it works. So this is another view of looking into the Docker components. So one is the Docker image, Docker engine. So Docker engine is the client server type of application, which means we have a clients who rely on the server. So basically Docker engine is a server. It's basically a Docker daemon, which is a Docker engine, and all the clients they run on the remote, but they connect to the Docker image for running their commands. So most of the communication happens via the RESTful APIs. Then we have a Docker image. So Docker images, okay, so I think this is the most important part. If we are able to understand the difference between Docker image and Docker containers, then the whole story becomes very simple. Okay, so if we see, Docker images are kind of a what we can say, these are the blueprints for creating the containers. So blueprint in the sense they contain OS binaries which are required, okay, plus your application software, plus any other software which is required for running your whole Docker application. Or let it make more simple. So let's assume Docker image is nothing but it is a ISO file which has a operating system and your application and everything already pre-built. Okay, and once you run this ISO on a particular machine or virtual machine, you get a complete machine with that operating system and already installed application. So that is what you can create a mapping. So though this mapping is not exactly correct, but just for understanding, basic understanding, you can say Docker image contains an ISO which contains all required applications and softwares for generating a virtual machine. Okay, and this virtual machine you can assume it to be a Docker container. Okay, so now let's read this definition. This will make things more better clear. So Docker images are the source code for our containers. Okay, we use them to build containers. They have a software pre-installed which speeds up the deployment. They are portable, hence we can use existing image or build our own. Now come to the Docker container. Containers are the organizational units of Docker. When we build an image and start running it, we are running it in a container. So container is a isolated execution environment provided by Docker where you can run your application or your Docker image. The Docker analogy is used because of the portability of software we have running in our container. We can move it, in other words, ship the software, modify, manage, create, and get rid of it, just as a cargo ship can do with its real containers. Okay. So, the simplest definition is the image is a template and container is a copy of that template. You can have a multiple containers of a same image. Okay, so I hope this makes little bit things clear, but going forward when we see the more things in action, then probably this will make things more clear. So these are like how you can install a Docker. We will see how we can install a Docker. So these are certain commands. So okay. So one is the Docker info. So I think let's do the hands-on. That would be more easier to understand. So we will do it on Docker on EC2 itself. So I might be already muted instance. Okay. So now we are connected. Let's see. We have a check here. Yes. So nothing is so now let's come to this topic and let's see how we can install it on Ubuntu or corresponding operating system. Okay, sorry, I was not showing you the So normally what happens since we are using this Red Hat, CentOS would be the more operating. Like if If you are running it on Ubuntu, then you have a direct apt command. You can just normally docker.io should be sufficient. Let's try simplest one. Sudo yum install docker.io. So this will be sufficient. Let's follow what they are saying. So this site sometimes they just overcomplicate the things. There's a simple command to install the Docker or Ubuntu, but they do it in other. Uh, but let's follow whatever they are. Mentioning. So we have a uniformity. It's already installed. Download it. You don't need a likely build. Install the stable version. What it is? 404. Then install. Uh, this is what I don't like. These documentation, they are very difficult to. Let's try once, otherwise we will just search it somewhere else. Notification goes into an account. Then install. They don't update their site itself. Did it install RT? Let's do it in a let's search Docker installation on. It's not actually that bad, but it's similar to that. Then install. Hmm. Let's leave it. Let's create a simple Ubuntu image. Let's create a simple Ubuntu instance. There we can try to install it. That is more simple. So let's stop this instance. Okay. And let's create a new instance. eDevOpsGuru, okay, security group, group, and let's add utility. Because what we will do, we will install a Jenkins using this Docker image. So let's use your here. Using here. Not yet. This will take little time to install. Okay, now we got the IP address. Now let's connect it. Okay, now let's run sudo apt update so that we have all the best packages. Now so if we install just so if you are not able to sometimes find what is the correct package, so just type that command and Ubuntu will give you what are the different commands to install. Just like in case I was not able to find the correct command, so what I did is I just typed Docker and then it gave me an option how to install it using apt as well as snap. So I will show you that thing. So here if you see this one. So I was not sure what was the command, so it just told me to run either this command or this command. So since apt is already
Hello, Anil.
Yes.
Sometimes your voice is very low. Can't hear properly.
Is it every time or sometimes? Is it better now?
No, sometimes while you are going through documents and while we are going through discussing a few seconds ago, it's very low. It's better now. It was very low actually.
Just let me know once again if it is low. Probably I will switch my earphones.
Yeah.
I don't have my original earphones.
It's better now actually. Yeah.
Okay. Fine. So okay. So what I was telling, like if you're not aware, like what is the command for installing a particular thing on Ubuntu, especially, so you can just write that particular command, and it will give you a small help. What you should do it. Like if you want to install using a apt, then it will give you that command. For example, in this case, sudo apt install docker.io. Or if you just want to go with a snap, you can also install it. Okay. So now we have a Docker installed. So let's see Docker version. Okay, so this is the Docker version which is installed. Okay, so now coming back to our documentation. So there are multiple commands which we can try. So let's try some of the commands just now. Docker info, Docker info. So it is telling type. This is error. This error, let's try to do it using sudo. Okay. So if you go and see, it will give you a lot of options. You can also see what is the state of Docker, which we have not yet started it. So you might not be able to see it, but let's see. Then there are certain commands like Docker pull means like to download an image. Since we have not yet pushed any image, so we won't be able to see. But let's see, run this command Docker images. So it will tell you what are the Docker images. So there are no images in our local repository. So we want sync it as an empty. So you can also run Docker stats. Okay. So it will tell you how much memory which container is taking, what are the IOs status, correct? So those kind of a things it will tell. So we will run these commands little later when we create some container. Okay. Then these are the commands to start stop containers. Okay. Then you can go inside a Docker. Sorry, you can go inside a Docker uh, and execute any command also. Okay, so this is a sample Docker file. So when we say a Docker file is a simple text file in a YAML format. Okay, so it tells what to do for a particular thing. So let's for example, let's try to understand this one. So this is a sample Docker file which will do a create an Nginx server. So if we just go and see, so this is first line tells you there is some mistake in it. So from should be next line. Let me see if I can modify it. So this should be like this. Sufficient. So this is what it is telling, like you want Ubuntu. So base image should be the Ubuntu. Okay, and this is the maintainer. So this is just like bookkeeping information. Then there are certain commands. So if you want to run a particular thing once that the Docker image is being created, so you can give it as a run. So what it will do while creating a Docker image, it will execute this apt get update command. Okay, and then it will run this apt install minus nginx command. Okay, so let me copy it and then I will show you how exactly what does it means like when I say these things are okay. So let's create here in things. Okay. Bi Docker file paste it. Hash is for the comments. Okay. So now coming back to the PPT, so this is what we have created. Okay. Now we have to build a Docker image. So for building a Docker image, simple straightforward command is Docker build, and then you can give a name to your Docker image. So Docker build. So if I just don't give anything, so it will see it now it has started generating a Docker image. So whenever it is generating a Docker image, in the background it is doing a lot of things. So let it finish and then. So what it is doing, so whenever it is creating a Docker image, basically it is creating a Docker container and then running those commands inside it. So if you see here, so first step it from Ubuntu, it downloaded this library slash Ubuntu. So this would contain all the libraries needed for creating a Ubuntu execution environment. Okay. Then here if you see, it created a container. Okay. So basically it created a Docker container, and inside that Docker container, if you just keep seeing it, so it added this maintainer key. Okay, then it started it, and then it removed the intermediate container which was created here. Then it started a new container, and inside that container it executed this command. This is apt get update. Okay, so once that everything is done, then it created another intermediate container and destroyed the original container. Okay, at the end, since I think there's value mistake, so correct it first and then -5. Let's send it back here. Okay. So now what is happening? For each and every command, it contains an intermediate container. Inside that intermediate container, it executes whatever commands you have given as a run. So like here if you see, it downloaded the engines inside that particular container. Okay. Okay. So here if you see, intermediate container, it was already started from there, and then it installed the engines inside that particular container, and once everything is compiled, correct, so from that container it created that Docker image. Now we have a Docker image. Docker images, Docker images. Now we have this unnamed Docker image in our local Docker repository, and this is the Ubuntu which it downloaded for creating the base container or base image. So basically containers or Docker is a layered architecture or layered file system where you have a one container, and on the top of that you execute some commands, then it creates a new container, or like you commit those changes into the existing container, and that container basically acts as a base for next execution of your commands in your Docker file. So at the end you will get a complete container which contains all your commands which you have done. For example, sudo update, or like if you installed some software, for example in this case Nginx, or like if you had installed JDK. So those kind of all things would be packaged into a single file, and that file we call it as a Docker image. So if we just see the size of this Docker image which we created, so it is 155 MB. So this contains 72 MB for your Ubuntu, then for obviously for your package updates and for your engine server. So this is how your overall Docker image is created. Now you can just execute this Docker image whenever you want. So whatever you executed in that Docker image, or whatever instructions you have given in a Docker image, they will be they are already executed, correct? And from that you already created this Docker image. So just need to execute this Docker image, and everything would be available. So if I just go and show this Docker image, Docker file basically. It's not Docker image, it's Docker file. So what it says, it will download Ubuntu from latest. Okay, so this is available in your Docker Hub. So I will show you from where it downloads this Ubuntu. Okay, then adds this bookkeeping information. Then it executed apt get update on Ubuntu. Basically, it generated a container using those Ubuntu Docker file, and inside that it executed apt get update, and then it executed apt get installed -5 okay, and then final image, it stopped the container and it generated or converted into a Docker image. Okay, so next time whenever you execute, so you will get a container which would already be having these things. So let's try to create a container. Okay, so we will understand what these images. So now build it again with the correct format. So we will just give a name -t. Let's give a name of custom regions. Okay, then followed by your tag name. So tag name can be okay. Sorry, first has to be the. Okay, since this time it took very less time because it had already cached your Ubuntu image and also like an intermediate containers which executed these steps, they were already cached. So it doesn't have to recreate those things. So if I just go and see my repository, Docker, so here you have a this named uh, image. So So here the convention for this one is the first name has to be your Docker repository name. Okay, then your image, whatever your Docker image name you want to give, so that would be there. Okay, so for example, this one, my image colon version name. Okay. So let's run it first. Okay, sudo docker run is the command. Okay. And since I think port is 80 minus B as a demo minus P is the exposed port. We will see what is exposed port. So mistake is there. Okay, so let's yes. What we did actually we created with a standard name, which is okay, so let's try to run the original one. So for the timing, I think we have created our Docker file, okay, and we have built it, and we can see it on a local repository. So repositories we will see little later how this works, but before that let's see. Let's create a web server using your Apache server and try to see how we can uh, execute or how to see the basic main page. So in this example, what we are doing, again we are using Ubuntu. We can also use other OS like our Red Hat. It supports, then it supports Alpine, it supports CentOS. So based upon your requirement, you can choose which operating system you want to host your application on. Correct. And this Docker file, or basically whatever the container is generated, so that may be running any operating system, say for example Ubuntu, and this Docker whole container might be running on some other operating system. So it may be possible, like on a Windows you have a Docker installed, and on the top of that Docker you might be have a Docker container which is running a Ubuntu, or maybe CentOS. So that is like how you can run a multiple environments on a particular host machine, and these environments, they are isolated. So one container cannot see what is inside the other container. So that is a all isolated environments which are provided by the container itself. Okay. So let's create another server, Apache server, vi docker 5, okay, paste it here. So if you see here, what we are doing, we are instructing Docker to download the Ubuntu from the Docker Hub, then create a container. It will create a container. Inside that container, it will run the apt-get update command. Then it will install the Apache. It will install Apache utils, and then at the end it will run the clean command, so that whatever the temporary files generated during the installation, they are removed, and then it exposes the port 80. So what does expose 80 means? Like once you create a container, uh, so this is a what you can say isolated environment, and if you want somebody to access any application running inside a Docker, you that application has to explicitly expose a particular port, basically port outside the container, so that any other application, or like or basically this application running inside this container can be accessed from the outside. So in this case, this Apache server running inside a container, it's by default runs on a port 80. Okay, so what we want, we should be able to access this port 80 from outside this container also. That's why we are exposing this port 80. So this, there may also be possibility, like port 80 is already being used by some other application on your host machine. So what you can do, you can also do this mapping, so that you can expose this port like this. You can change it. You can change it to 8080, and then map it to the internal port. So in this way, this internal 80 port, Apache would be running on a port 80, but from outside you will be accessing it using port 8080. Okay, so that kind of a mapping also can be done. And then this is the command. As soon as this container is started, so basically it will run this command. So this Apache would run in a as a daemon in a foreground. So you can execute any other command which you want to execute like if you want to pass some environment, you can also pass, or if you want, as soon as this container starts something, some other command should also be executed or some file should be created. So those kind of a things you can pass to this container via command. Okay, so let's build it. So docker build. You can also give the file name -f, but since this Docker file is still in the same folder, we can just give a dot. Okay. Then name it using the tag Apache server. You can also give a version if you want, like 1.0, 1.1. So you can also give a version. If you are creating multiple versions of a Docker image, you can uh, name the, or you can version those things also. Okay, so copying it is some problem, and it does not like this. Okay. So it's basically same as like if you were doing it in a VM, but instead of a VM, it is just creating a Docker image, which let's say this. So once this Docker image is created, so running it is just a matter of a couple of seconds, not even seconds. So you can give this Docker image to anybody via the hub repository or your private repository, and then they should be able to just run it straightforward. They don't have to do any configuration. If you have already done that configuration as a part of the Docker image, or if you already installed a set of images, you can also fill up. Person doesn't have to do it again. Should we run it again? Let me run it again. Okay, let it run here. So meanwhile, we can just discuss what are the types of repositories. Uh, Docker Hub. So Docker Hub is the central repository, public repository. You can create your account and then access it. You can push your images directly to this repository. But in most of the organizations, or enterprises, you would not see them using this GitHub. So they will be having uh, their own private repository because they don't want to expose their code or binaries outside world. So they will be having their own repositories, but still this will give a better picture how repositories work. And if you want some base image, you can also explore it. So if I just give an example how MySQL works. So how MySQL Docker image is created. So if you see, you will find lot of images here, Docker images. So one is this. So this is the official image. So you will find some Docker certified images. You will find some official images, or it might be possible like some of the people, they might have customized and pushed their Docker images. So this might be see from comments, experimental MySQL cluster Docker image. Okay, created by MySQL team at Oracle. So these might be some like somebody might be testing it and putting it, or somebody might be just doing their own customization and putting it on a Docker hub. Okay, fine. So, but let's see one of the official image. But okay, so before that, one important question: how would you make sure like you are using the right image? So first is obviously you have to look for official image, and you also can verify it from how many downloads it has like happened. So in this case, there are 10 million plus, and this is also like MariaDB. But if you see other, so here it is 5 million or it's just 10,000. So we should go with the image. If it is not officially official image, then the highest downloaded images, and you can also see when it was updated and how frequent it has been updated. So that would help you to get the best of stable images. So if you see here, okay, so this will give you how to use in your code. So if you just want to use in your code, you can just run this docker pull MySQL command. Okay, and these are the different versions which are available. So you can choose like this one, docker pull MySQL colon, for example 5.6, if you just want to download Docker image 5.6, or if you just want to go with the latest, then you can say colon latest. Okay, so Docker compose we can see, but let's see, maybe we will spend some time. Okay, so why it is okay. Let me something else. Okay, so let's start with the Jenkins. Okay, vi Docker 5. So first we need to write what image you want, Ubuntu. I think there's an issue with Ubuntu also sometimes, but let's see. Then the mandatory tag is to run, okay, where you can do the sudo apt get update. Okay, then let's see if you want to install Jenkins. Okay, so you could do a wget. You just give the complete path. Okay, where you will find the Jenkins.war file. Okay, and that's all. And if you want to do some other configuration, you can also do that configuration. So this is how you can create your own Docker file. But I will give you a better example how to create your own file. So Jenkins. So Jenkins, if you go, so these are the different versions available. Okay. So let's run this in local machine. So you can also run local Jenkins locally also. So here it will download Jenkins from the Docker Hub, not your local repository. First, it will search in your local repository. If it is there, it will pull it from there. But if it is not there, then it will basically download it from the GitHub. So if you see this documentation, you will get everything like how to run it, how to execute it. So if I see, this is how we should run it. So this is a Docker run. So Docker run will create Docker image, basically Docker container from this image, map port 8080. So basically 8080 is the internal port, okay, and minus P is like this one is the port which is exposed outside. So you can change this port as per your convenience. If this port is already taken up, you can change it. Here it is also exposing 5000 port, which is for administration. So let's copy this. This one we don't need. This will be okay. So now Docker. Now we have a Docker running in your machine. So basically, what it will do, it is just executing whatever is there in the Docker. So see, now we have got this credential. So what exactly happened? So if you just see, okay. So it created a container, and inside this container, it started basically started running this war file. Okay, it itself sets some environment variables, and then started that war file. So it's everything is done. Now you can access this on your machine. Just public IP. Port 80. So you should be able to see this statements. So this is the one part, but how did it create uh, this Docker image? So that is also available. Let me see. Some of the developers, they put in that information also. So here you can see there are multiple options also. Like for Alpine, if you want, this is the Docker image. This one. Similarly, for other operating systems, you will find it. These are the Alpines. So there are multiple versions and operating systems. Let me see if I can show you for this particular example. I think they have not given this information for this particular. Okay, so this is what I was trying to show. So these are the how the multi-layers, or like this is basically your how Docker image was generated. So but still this is not giving the complete text, but it is just giving you how it was executed. So this added a file something, then it started bash command. Inside the bash, it executed this update command, then set the language, and all these things were done. And you can also see what size it added to, like this update added 30 MB of files, and then it created user Jenkins, group Jenkins, and these resulted in 0 bytes of size increase. Okay. And you see and go, and then you will see each step and what size it added to. So this is how your images, but still, like, I just wanted to show you something else, but it is still this developers, they have not put in that information. So otherwise, you could see the complete Docker file which they use for generating this Docker image. So let's see, they have it something. I just forgot to copy that. I don't think it is there for this. Okay, so this was the basics of the Docker, how you can execute, how you can run. So there are multiple parameters of this when you run this Docker image. So obviously, -d is the daemon. It will run as a daemon in the background. -p is the port which you will publish. So this is the internal port, and this is the published port. So published port may be same as your internal port, internal container port, or can be different. If you expose this mapping, then all the requests coming, or all the requests which are made on this particular port, they are automatically converted to this internal port by container itself, and so basically it works as a NAT in that case. Okay. So this was the basic one. Then now let's talk about the little bit advanced part. So okay. So now Docker image, how it can create a it can create a container. So Docker Compose is basically, it's a tool where you can define and run multiple containers. So it may be in most of the cases it's just not a single container. Your application will be so your application, there might be a multiple applications in uh, your deployment. So basically there would be a one web server, there might be a another database server or something else. So how do you manage, and how would you define and create your Docker in a single file? So Docker Compose gives this functionality. So Docker Compose builds a stack of applications to run a complete service. Okay. Then using a single command, you can create all the services, you can stop all the services, or you can manage them using a single command. So Docker Compose, it works in all environments. So it can be used for production, staging, development, testing. Okay. So Docker Compose basically can manage the complete life cycle. So it can start, stop, rebuild your services. You can view the status of your all the services which are defined in that particular Docker Compose file. You can also logs, see the logs, or you can output your logs to your out console, and there is a single command to turn off all the services. So this is one sample Docker Compose file. So it has a multiple sections. The first one is basically the version. Then you have a services. So services is basically Docker basically section for defining your containers. Okay. So here we have one service which we name it as a web. So this would require an image, Docker image engines. Okay. Then you have a DB service for which you need an image which is named as MySQL. So these images can be a local images, like these might be present in your local repository, and if they are not there, then these would be pulled from the GitHub repository. Then you can define ports. If you have some port mapping, you can define that port mapping. You can also set the environment variables. Like in this example, we have set the environment variables, like what will be the MySQL password, what will be the MySQL user, and those kind of a default database and password. So whenever this container is created or this Docker is created, these configurations, they are pre-built. So okay. And format for this compose file is YML file. Okay. So let's see if we can create a Docker file and execute it. Oh, this one just got disconnected. Disconnected. Okay. Let's So since this is a YML file, the formatting or indentation is very important. This is just a sample example. So these are not interrelated. Engines is not using MySQL, but I'm just trying to showcase that multiple uh, applications which makes your application stack can be defined here, and they can be started and stopped, or like all those management can be done using Docker Compose itself. So first command is Docker Compose, but since we don't have a Docker Compose installed, so we will get as let's install Docker Compose. So Docker Compose is basically just a kind of a wrapper on the top of Docker. So whatever you were doing for a single individual Dockers, so you can do it from single place which is called the Docker Compose. Okay, so now we have a Docker Compose ready. So now run the Docker Compose up. So up will create containers. Okay, and if so let's see. So basically, if containers are not already the images for required for those containers are not there, it will download. Uh, and if it is already there, it will just pick and start creating the Docker images. Now, if you see here, so it just pulled the MySQL. Okay, some of the things it was already there, so it did not pull those things. already there, so did not put that part, but then it pulled other information. Okay, so we downloaded the MySQL latest, and now it is up. So if you see here, now it has started the web as well as Postgres. So let me run it again in our background mode so that we can check other things. It is stuck somewhere. Is it issue with my internet connectivity? Let's do one thing. Let's restart the instance. Probably this instance has some. This Ubuntu, I think Ubuntu instance has some problem. Last time also when we tried to compile the code, we did not compile it. We had to switch to the Amazon AMI. But now the IP address would be changed. No, it did not restart it. But option image stop. So while it is restarting, so these are the some basic commands. So this is the Docker Composer. So it will deploy, build if needed, correct? And Docker PS is basically like if you want to see the status of containers, so you can do the PS. It will list the Dockers which are running. Okay. If you want to shut down or destroy the containers, you can uh, run this command Docker compose down. So there are other commands like if you want to stop temporarily the running containers, you can also do the Docker compose uh, stop, and then you can start it. Let's see now. It's still stopping. So there might also be sometimes issue with the regions, so you can always go and check the uh, status of your regions. But normally instance is running. Okay. Now it is stopped. Which one we created September 26th. So last one is what we created. So let's start this. Somehow things are very slow. But, let's see. Now we have a new IP address. Now let's try to copy. Okay, this is the new one. Yes. Okay. So now go to that folder which we created. Docker compose. Docker compose up sudo -d. So it would run as a daemon in a background process. So you can always get back to your store. So now if you see Docker compose ps, you can see you have two containers. One is DB and another is the web. Status is up. This is how you can access those. So one is available on port 80, another is available on port 3306. So if I see port 80, but in our security group we don't have a port 80, so let's enable port 80 in our security group. Security group. Inbound traffic. Okay. Edit it. So port, let's change it. Okay, now we go. Now let's see what is the IP address of our instance. That's the IP address. This is IP address. And we have port 80. Why is this not opening up? Port 80. We have to enable the security group. Let's see the HTTP is enabled. Source, I think source will be right in this way. Let's see. Why it's not showing this. By default is port 80. We don't need to specify it. But let's Okay, so now let's try to debug it. Coming back to, we will see how it failed. So now let's go back to the Docker part. We have this command to debug. Okay, no issues. Let's see. Docker log, then the name of your container. Docker sudo. So as per this, this is up. Okay, let's open Docker file. Okay, sorry, it's my mistake. Why it is not accessible? Because we have not exposed the port. Okay, so let's expose this port. The internal Docker port is open, but this Docker port is not exposed to the outside port. So that's why we are not able to access it from the outside this Docker. So once we do the changes, what we can do, Docker compose down. So this will delete all your containers. So there is some mistake. Okay, ports. What is the mistake? That is okay. Colon was missing. Basically, since this is a blue screen, so this is not very visible, but here you have a colon. Now these have removed everything. So if I just go and show you the Docker, yes, so there is no open running container. So now let's run it again. So now the Dockers are created. See, Dockers are up and running. If you want to see the logs of a particular Docker, you can see the logs. Okay. Now let's try to connect it. Yes, now we can see, we can connect to the server which we installed on. Okay, so this is how Docker Compose helps you in running the services all together. Okay, so now what is left in advanced part. So this is how Docker Compose file works. These are the commands to create, stop, or run it. Okay, so there is one more command which is not mentioned in the PPT, but we can use it. So we can stop the running containers also. Okay, so now these containers will not be destroyed, but these would be just stopped. So now if you see, these are stopped with state as a exit 0. So we can run it again using the start. So these will temporarily pause and resume kind of a functionality. Okay, so these are up again. If you just want to stop a particular service, you can stop it temporarily, and if you want to just destroy the everything, you can destroy it. Okay. So one more important thing is when you create a container, so the storage inside this container is temporal, so it's just a non-persistent. So as soon as you destroy a container, whatever logs are generated or whatever the configuration files or whatever settings you have done, they will be destroyed, because container provides a exclusive environment, and as soon as that container goes away, that everything inside that particular environment, that is also destroyed. So next question is, how would you persist your logs, for example, or how would you read some information from outside the container. So there we have a concept of volumes. Okay, so we can, let's try to change this compose file itself. Docker compose. So here, what we can define, we can define volumes. Okay, and here we can specify what is the our local folder which could be mounted inside the containers. So for example, I say current folder that should be mounted as temp inside your engine server. Okay, so now if I stop this command, stop these containers and compose down, okay, and restate it again. Okay, now let's see. Open this up again. Okay, now let's go inside the engines container and see uh, what exists, what exactly is inside the engines, and whatever the volume which we have created, does it exist? Okay, so for that, sudo, we have a command sudo docker execute minus it, then the name of your container, okay, minus slash dash init, sorry, bin. So this is how we can get into the container. So these are the different, you can say what is inside a particular container. So if you are aware where this engine is installed, you can just go and see. But what we are interested in seeing is the template folder. So see, if I show you my local current folder, I had a Docker compose file. So now since I mounted that local folder from where I executed this command into this Docker at /temp path, I can see all those files, okay, which are there in the host machine, or like from where I executed this Docker command. So now let's see. Let's assume like if there was some logs folder, and if I had mounted that log folder to some other host machine, and let's say such log.txt. So let's assume like this Docker is generating a log file and writing to this file. Okay, so if I see here, I can find it. So basically, this particular folder, this current folder, I have mounted to this particular folder. So similarly, like if I know what is the log folder inside this engine server, I could mount it to any local folder. So it could be /mnt or /data folder or current folder. Correct. Similarly, if this particular software needs some configuration file, we can mount and share that path to this. Okay. So this covers almost all the different aspects of uh, aspects. Okay, so I think this is one more example. Okay. How you can do it. So this is the example which I created so that you could run your own application. So what this is a kind of a lab hands-on also. Okay, so create a folder, eDevOpsGuru Docker file folder, and inside that create a web apps folder. Okay, and inside that just write the create an index file and just put some header on it. Okay, then create a Docker file with this content. So basically, this would pull Ubuntu latest from the Docker hub, execute update commands, and it would install Apache 2. Okay, and then copy index file to this one. So basically, what it will do, it will pick your index file from your local host machine, and it will copy to the Docker file, or like that container, which is intermediate container which is generated. Then it could set the working directly to var www/html, and then it will once this container is started, it will tell that this command should be run and port 80 should also be exposed. So basically, this will generate a Docker image with your Apache server and a default index.html file. Okay. Then next, we are creating here a Docker compose file, which will basically run MySQL file, MySQL server, correct, with password as a secret, and MySQL DB would be the container name. Then I will create a web service. I would need to pull Apache uh, Docker image. Okay, if this does not exist, then we can also build it using this Docker build. So this will go into the web app folder because inside the web app folder only we have this Docker Docker file. Okay, so this will build it, and then this will wait for Postgres server to be up, and then it will expose port 8080, and this application you can just host it. So it's just follow these steps and try to bring it up. This will help you to create your own Docker image. Okay, and using Docker Compose, how you can build it and you can deploy it. So if you want, we can execute this right away. So let's load it. Lab hands-on API lab hands-on. What it takes is create this particular folder. Okay, cd eDevOpsGuru, then create NCDI web app folder. Just create the file. Basically, inside the web app files, you have an index file. You just give the contents. Contents is just no HTML header which we had added. Let's create a Docker file with these contents. vi Docker file. Okay. Now we have a Docker file. Then inside the eDevOpsGuru folder, which is basically sorry, this Docker has to be inside the. Let's move this Docker file into the web apps. Okay. Here we have to create a Docker compose YAML file with this content. Let's use nano. Okay. Fine. Use control X to save it. Now what we need to do, since if we run it, Docker compose up -b, so it will not find those okay, so there is some issue here. Let's open the Docker. This is okay. What is Docker file has some problem. Okay. So vi web apps Docker file. Okay, so this is from is specific. So what it will do, this image did not contain it, so it's just trying to create a Docker image. Okay. I think it will again be stuck with the region itself. I don't know what is the issue with this one, but you can try it and let me know if you still face issue. Otherwise, you can run it on other non-Ubuntu operating system. Just create a Docker this AMI using some other one and then try it. So I think this so basically this will execute like since we have created this one build. So what it is searching is like inside the web, it is searching for the Docker file, and if that image is not there, it will run this Docker file, create the Docker image, and then pull it from that image, this generated image, and then it will start the container, and then it will do it for the database, and at the end you should be able to access your own page, which is basically it works using this port 8080 on web browser. So this is what you should be able to see it. So let me put it on a Slack channel so that you can refer it later also. So that's all for today from my side. Is there any questions which you would like to discuss, or if you have any doubts, we can discuss it now, or otherwise Slack channel is always open. Okay, fine. Then let me stop the recording.